Okay, in this video, we're going to use our trig ratios, sine, cosine, and tangent, to actually find missing sides or missing angles in right triangles. And just a real quick reminder of what sine, cosine, and tangent are. We will be using those trig ratios. Like I said, we need to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent as we work these problems. So here's how we're going to work these. We're going to first try to decide what type of problem we actually have. We're going to find our angle, and we're going to look at the sides that we're dealing with in the problem. Like here, we're dealing with the opposite side and the hypotenuse, and we ask ourselves which of the trig ratios deal with opposite and hypotenuse, and that would be the sine. And we're going to write our equation to begin with, the sine of an angle. We always start with our angle in parentheses there. The sine of the angle is equal to always opposite over hypotenuse. Now, a lot of times people get into a habit of just always putting the x on top, and that's not always the case. The reason x is on top here is because sine is equal to opposite, and since the opposite is x, that goes on top, opposite over hypotenuse, which is 25. From there, we simply solve the equation. To get x by itself, to get rid of divided by 25, we mark it out, we multiply by 25, and we simply type this into our calculator. 25 times the sine of 25 times the sine of 64 gives us an x value of 22.5. So our missing side there is 22.5. Next one, here's my angle. This is the opposite side. This is the adjacent side. Tangent is the one that deals with opposite and adjacent. The tangent of an angle, in this case 47 degrees, is equal to opposite over adjacent. It just so happens x is on top again. To get x by itself, we mark out our 12. Since being divided, we'll multiply. Type 12 tan of 47 into our calculator. We get an x value of about 12.9. And I do want to point out that 12.9 is really close to 12. And the reason for that is this is nearly a 45, 90. There's only 2 degrees off. So that's the reason these side lengths are so close to each other. It's nearly a 45, 90 triangle. Number 3, here's my angle. This would be the opposite side. So this is the adjacent and hypotenuse that we're dealing with. That would be cosine that deals with adjacent and hypotenuse. So the cosine of my angle is equal to adjacent over hypotenuse. Same thing, to get rid of divided by 34, we're going to multiply by 34. Type into our calculator 34 times cosine of 18. And we get a value really close to 32.3. Number 4, a little bit different on this one. Here's my angle. This is the opposite side. This is the adjacent side. That would be a tangent problem that deals with opposite and adjacent. The tangent of my angle is equal to opposite over adjacent. And what makes this one different is, again, the x is on bottom now. Now, the shortcut for when x is on bottom, what we could do, we could set this up like a proportion, put it over 1, solve it like a proportion, 1 times 9 divided by tan, 35, but there's an easier way. Anytime x is on bottom, the shortcut is you can simply switch the x and whatever's on the other side. So x is now going to equal, I moved it up here, I'm going to move the tan of 35 down here, 9 divided by the tan of 35. And that's what we're going to type into our calculator. Again, that's anytime x is on bottom, simply switch it with what's on the other side. And what you're doing is you're multiplying to get it over here. And then once you get it over there, you're going to divide to get the tangent of 35 over there. So we type this into our calculator, and we get an x value of about 12.9. Number 5. Here's my angle. This would be the opposite side and the hypotenuse, very similar. Opposite and hypotenuse would be a sine problem. The sine of my angle is equal to opposite over hypotenuse. Since the x is on bottom, we can use our shortcut. Move the x to the left side, move the sine of 63 to the bottom. So we have x is equal to 27 divided by the sine of 63. which is about 30.3. So our missing side length there is about 30.3. Now, number 6, we should recognize something special about this problem, and there is a shortcut here. And we'll talk about the shortcut in just a second. But here's my angle. That would be the adjacent and the hypotenuse. So this would be a cosine, because cosine is adjacent over hypotenuse. The cosine of my 30-degree angle is equal to adjacent over hypotenuse. We can use our shortcut. X equals 18 divided by the cosine of 30. We can type that into our calculator, and we get 20.8. But again, there is a shortcut there. This is a 30, 60, 90 right triangle, and just a quick reminder of the shortcut is everything revolves around the short side. To go from, and this would be 2 steps here, to go from the longer leg to the shorter leg, we're going to take 18. We're going to divide it by root 3 is what the shortcut is. Once we get that answer, we're going to multiply it. In order to go to the hypotenuse, then we're going to multiply it by 2. And once you type that in, you would actually get that exact same 20.8. Okay, the next part of the lesson, we're going to be finding angle measures. And anytime we're looking for an angle, we're always going to use inverse sine, inverse cosine, or inverse tangent. And the reason for this, the same way when you're solving an equation, and to get this x by itself by moving plus 3 over, we subtract 3. We do the inverse operation or opposite operation. And that's what these are, is these are simply opposite operations. And let's say it says, if you know the sine, cosine, or tangent ratio of an angle, you can use the inverse of the ratio, and we see the 3 inverses there, to find the measure of the angle. So here's what we know. If the sine of theta is x, then theta will equal the inverse sine of x. And again, all that means is if we wanted to move our sine to the other side, we simply do the inverse sine. And it's the same way with cosine and tangent. If we know cosine of theta is x, then theta would be the inverse cosine of x. Again, we're just moving it over. And to move tangent over, we would turn it to inverse tangent. And we're going to use this to actually find angle measures. So let's start this with number 7. And we start the problem the same way. Here's my angle. This would be the opposite. This would be the adjacent. So that would be a TOA, a tangent problem. The tangent, and I don't have an angle, so I leave it as theta here. The tangent of theta is equal to opposite over adjacent. Now, in order to get theta by itself, which is what we're looking for, the angle here, we're going to move the tangent over. So all I've got to do is say that theta is going to equal the inverse tangent of 8 over 14. And you do have to type that in. Make sure you put these in parentheses in order to get the right answer, but your angle is going to be 29.4 degrees. Next problem, same thing. Here's my angle. We have an adjacent side and a hypotenuse. Adjacent and hypotenuse would be a cosine problem. The cosine of my angle is equal to adjacent over hypotenuse. To solve that, again, we're going to move the cosine over. Once we move cosine to the other side, it becomes the inverse cosine. We're going to find the inverse cosine of our 2 values there, 38 over 40. Once we type into our calculator, and on our calculator, we'll use the second cosine, the second button to type in our inverse cosine. Once we type in the inverse cosine of 38 over 40, we get 18.2 degrees. So our angle there is about 18 degrees. Number 9, more of the same. Here's my angle. This is my opposite side. This is my hypotenuse. Opposite and hypotenuse would be a sine problem. The sine of my angle is equal to opposite over hypotenuse. To move the sine from one side to the other, we're going to simply turn it into inverse sine. So we're going to do the inverse sine of 17 over 22. We type that into our calculator, and we get that our angle is equal to 50.6 degrees. The next one, number 10, here's my angle. This would be the adjacent and the hypotenuse. So that would be a cosine problem. The cosine of my angle is equal to adjacent over hypotenuse. To move the cosine over again, we'll turn it into inverse cosine since we're looking for the angle. The inverse cosine of 11 over 48. We type that into our calculator and we get 76.8 degrees. Okay, starting on number 11, we're actually going to apply sine, cosine, and tangent. And we're going to be using it to find answers in problems involving angles of elevation. Now, what we need to know about angles of elevation is it's our line of sight is what we're talking about here. So if you were to actually be looking straight ahead from your eye, that would be a horizontal with the ground. It's very important that you measure from a horizontal, and then you tilt your head up from there. And the amount of angle that you tilt your head up, we call the angle of elevation. This is our angle of elevation. And again, it's measured from a horizontal. When I say horizontal, it's horizontal with the ground. And then we tilt our head up from there. Again, our line of sight forms an angle of elevation, and that's what we mean by that. So on number 11, it says the angle of elevation from a fishing boat to the top of a lighthouse is 5 degrees. So we have, I'm just going to put a dot for my boat, and then we have our lighthouse over here. I'm going to draw just a stick, and there's the top of our lighthouse. And here is our angle of elevation. And it says that the angle of elevation from a fishing boat to the top of the lighthouse is 5 degrees. If the top of the lighthouse is 161 feet above sea level, how far is the boat from the lighthouse? Here's the boat, here's the lighthouse, the base of it, and we're simply looking for x. So we see that even though it's a word problem, it's going to be solved the exact same way. Now, we're not looking for an angle here, so we're not using inverses. We're simply looking for a side length. So here's my angle. This is an opposite and an adjacent. So this would be a tangent problem. The tangent of my angle, 5 degrees, is equal to opposite over adjacent. We do notice the x is on bottom, so we will have to switch the two. So we have x is equal to 161 divided by the tan of 5 degrees. Once we type that into our calculator, we find out that our x value is 1,840.2, and it was measured in feet. That's how far my boat is from the lighthouse. Number 12, the angle of elevation from the bottom of a slide to the top of the slide is 44 degrees. So again, the angle of elevation from the bottom to the top of the slide, there's my slide. It's a 44-degree angle of elevation. If the top of the slide sits 16 feet above the ground, find the length of the slide. Now, this is the actual slide right here, so that's my x value I'm looking for. Here's my angle. This is opposite the hypotenuse. That'd be a sine problem. The sine of my angle is equal to opposite over hypotenuse. Again, notice the x on bottom, so we're going to have to switch it. So we have now x is equal to 16 divided by the sine of 44 degrees. We type that into our calculator, and we get 23.0 feet is the length of that slide. Number 13, a 10-foot ramp is used to unload furniture from a truck. If the back of the truck sits 3 foot above the ground, find the measure of the angle that the ramp makes with the ground. So here's our ramp that's attached to the back of our truck. We know that the ramp is 3 feet above the ground. It says the ramp is 10 feet long, and they want to know what our angle of elevation is, and we'll call it a theta there. So we're looking for our theta. We are dealing with an opposite and a hypotenuse. So again, that would be a sine problem. The sine of my angle is equal to opposite over hypotenuse. Since we are looking for an angle, in order to get my sine to the other side, again, we will turn it into an inverse sine, the inverse sine of 3 over 10, and simply type that in our calculator, and we get a 17.5 degree angle. Number 14, A fire is spotted on top of a 125-foot tall tower if the angle of depression. Now, in these problems, before we go any further, let's talk about what we mean by angle of depression. So if you're on top of something, again, we're talking about from our line of sight. If from your line of sight you look downwards, then here's my line of sight now. That is called your angle of depression. Now, I do want to remind you of something from geometry. So if somebody is here looking down, this would be their angle of depression. If somebody is here looking up, this would be their angle of elevation. So they're looking at each other. These are horizontal with the ground. Since they're both horizontal with the ground, that means they are parallel. And this would be, from geometry, what we call a transversal. So since you have parallel lines cut by a transversal, these two angles are actually what we remember as alternate interior angles, and they're congruent. An angle of depression would be congruent to an angle of elevation. Just keep that in mind. So number 15, it says 14, a fire is spotted from the top of a 125-foot tower. So let's draw this tower. It's 125 feet tall. A fire is spotted if the angle of depression to the fire is 19 degrees. So we got to be careful here. So our angle of depression, so let's draw this. Remember that we actually have to draw it from a horizontal with the ground. So if the angle of depression, we're here looking down at the fire. So this is our 19-degree angle. And notice that that angle is not part of our triangle. But from what I just told you, if that's 19 degrees, then the angle of elevation also up to the fire will be a 19-degree angle. How far is the fire from the base of the tower is what we're looking for now. So we're looking for our x value. Here's my angle. We're dealing with opposite and adjacent. That'd be a tangent problem. The tangent of my 19-degree angle is equal to opposite over adjacent. Let's switch the two since the x is on bottom. So x will be 125 divided by the tan of 19 degrees, which is going to equal about, we'll call it 363 feet. Number 15. An airplane is flying at an altitude of 8,900 feet over water. The pilot spots a raft floating in the water at a 28-degree angle of depression. So our height is 8,900 feet. And they spot somebody, let's see, in a raft floating at an angle of depression. Here's the raft over here. And again, that angle of depression would be this angle. That'd be a 28-degree angle, which is also the angle of the elevation from the raft back up to the airplane as well. So there's the 28. And we want to know what is the horizontal distance. And horizontal would be this distance right here. This would be our vertical distance. This is our horizontal. And this would actually be our true distance away from us. So we're looking for the horizontal distance. Here's my angle. We are dealing with opposite and adjacent. So that'd be, again, a tangent problem. The tangent of my angle is equal to opposite over adjacent. Again, we're simply going to switch our x and tan. So x would be 8,900 over the tan of 28 degrees, which gives us 16,738.5 feet. And the next one, number 16. Max is sitting in the stands of a baseball stadium. He catches a foul ball and decides to throw it back to a player standing on first base. If the horizontal distance from Max to the player is 61 feet and the ball travels 76 feet, what was the angle of depression from Max to the player? So here's Max up in the stands, and he's above the field, and here is his horizontal distance. There's the flight of the ball. And this is the player on first base here. So it said he's sitting in the stands. He catches a foul ball. His horizontal distance from Max to the player is 61 feet. That would be this distance. The ball travels 76 feet. So the ball is actually traveling along this path. And we want to know what the actual angle of depression, and again, we're looking for this angle of depression, which I want to remind you that's the same as this angle of elevation. So that's the angle we're looking for. So we're dealing with an adjacent and a hypotenuse, so that'd be a cosine problem. The cosine of this angle that we're looking for is equal to adjacent over hypotenuse. In order to find an angle, we're going to move the cosine over, so theta will equal the inverse cosine of 61 over 76, which is going to give us a value of 36.6 degrees.